Okay, I want to think we need to talk real quickly about the normal distribution, or what we think of when we're talking about a distribution. This is a theoretical concept, and we would think that anything that we're studying, it's normal for what it is. And we talked a lot earlier about sample and population. We're taking samples from the population. We're assuming the population is normal shaped. Okay, and so the normal distribution, we're going to talk a little bit about quickly. Bell-shaped, symmetric, sometimes called the bell-shaped curve, never touches the x-axis, completely describe its mean and standard deviation. Now, we haven't discussed those numbers or what those mean just yet, but we'll look at that a little bit in the future. So first of all, normal distribution, it's basically this shape that we all think of when we think of the bell-shaped curve. Sometimes, you can have curves that are normal curves, and you'll see these are not necessarily bell-shaped. It may be a real tall bell here. They can have different shapes. That just means how much they're spread out. But the main point with the normal distribution is that they're symmetrical. This side of the curve looks exactly like that side, regardless of whether they're tall or short. That's just the spread out of the numbers, right? The range of the numbers that make it kind of spread out. So these numbers in this one would be tight. So, okay, say let's just make up numbers. This is from 1 to 10. This one might be from 1 to 50, and this could be from 1 to 100. That's just how they're spread out, right? Your numbers. So this talks a little bit more about it. Of course, again, if you fold it in half, 50% is one side and 50% is the other side. Everything, 100% of all of your data, or all of your numbers, or all of your data points are under this curve. Now, the one thing that's interesting to see here, again, it says theoretically, because we're talking about theory and probability. We're not talking about definite 100%. We can get 99%, or 99.9, but we can never always be 100% sure. So this is theoretical. This here line never touches this axis here. It always goes out. It goes out for infinity. So there's always something that we can't explain, and we've kind of talked about that in the past. In the normal curve, your mode, median, and mean. I have another video on those, but the mean, of course, is your average. Your average number is in the middle. The central tendency, because they tend to center around the middle. But the mode, median, mean, the median is the middle number, the mean is the average number, and the mode is the most frequently occurring number. All of those are the same in a normal distribution. Now again, remember, when we're taking samples, that normally is rarely the case. However, this is what we're trying to say. If we said, well, what is the normal blood pressure? What is the normal ounces of chips that are supposed to be put in every bag coming out of the machine? We would say that this is what it's supposed to do, right? Anything that deviates from the population, the normal, is what we're trying to find out what's going on, right? Or we have a theory on why something is causing that, right? In this case, we want to talk a little bit about the empirical rule, but let's go back and understand what this is about. Is 100% of our data is underneath of this curve, right? Everything, 100%. So if we chopped it up and we says, okay, well, the most frequently occurring number, the mode, is here in the middle, and so therefore those numbers that tendency to come around the mean and the median and the mode are the most numbers. So you'll know that you'll see these lines kind of going across here. The empirical rule says that 68% of all the data will fall between a minus, we're going to call this 1 standard deviation, and 2 standard deviations. I'm sorry, a -1 and a +1. So this is 2 standard deviations from -1 to +1, 0 being in the middle. But the idea is this part of the curve contains 68% of all of our data. Now we go out 2 standard deviations from the mean or the median or the mode, and we're over to here, and from this point, you see this is the green line, if you can see that there, the second line out, the green one, from +2 to -2 standard deviations, so that's 4 standard deviations in total. That's 95% or 95.4% of all of our data will fall between these 4 standard deviations, -2 away from the mean and +2. And then obviously now you can see the next one, we're going to go out 3 standard deviations. And 3 standard deviations, all of our data, or not all of it, I should say 99.7% of our data is going to be between these 6 standard deviations from the mean. Now remember, you can have numbers that's way out here. That's given that in science they allow for those kinds of things, and we see those kinds of things. But this is what we're just calling the empirical rule. We can calculate probabilities based upon this. And so remember, we talked about confidence interval, and I said, well, what's 95% confidence level? Well, I'm 95% confident that the data between these 4 standard deviations is going to include the population mean. Here's just another little picture of it. It talks to you about this. It's pretty much the same. It's kind of showing the 95% up here. But think about this. So where we're headed with this is we're trying to test hypothesis. We're trying to say what makes something different. This is, what you might study. What makes something different from the norm? If a person has the normal blood pressure, who is it or what is it that causes somebody to have high blood pressure or low blood pressure or something of that nature? If we're putting those potato chips in the bag and the machine is supposed to put in so many ounces for every bag, what is it that causes that? And so how do we know that something is different enough from normal that, see, this is normal, right? The mean is normal. How far does something have to be different from normal to say, hey, we need to, if you got high blood pressure, maybe you need to watch your diet, and things like that. Do a little exercise maybe. But if it's something like, well, now you're farther away from the mean, you need to do, you maybe need to take some medication because now you're farther away. And then the other one is like, oh my gosh, you're so far away from what's normal or the mean of the population that you need to be rushed to the hospital. Maybe you need surgery or something. And so that's kind of what this is about. And so you'll see here that we're actually headed towards the time where we're going to test a hypothesis. This was blood pressure, and we'd say, well, this is the normal blood pressure right here in the middle, right? And then if your blood pressure is way over here, right, we need to say, we need to do something. And the question is it just, change your diet, or is it, take a pill, or maybe rush to the hospital? And so that's what we're going to call, what is that critical value? What is the critical thing that's going to mean that you're critical? Your blood pressure is critical, and we need to do something. And so think about that when you're trying to remember this when we start talking about critical value. That's what we're going to try to determine, is what is this critical value that's going to make a difference, because we're studying differences between means, the mean of the population and the mean of maybe some group of people, or a group of bags of chips compared to the normal bags of chips, or whatever it is that we're talking about. I'm going to stop here right now, and then we're going to come back and we're going to discuss that critical value. Where do we get that? Where does that come from? And how do we determine whatever it is that we're trying to study and whether or not it surpasses the critical value?